Okay, now we're going to look at some more examples of these parent functions. This one's called the reciprocal function. It's y equals 1 over x. So we're going to start by plugging in a -2 for the x, and that gives us -1/2. When I plug in a 0, I get 1 over 0, but that's actually undefined. In this situation, we actually have a vertical asymptote when x is 0. Okay, if you look at the graph, you can see that vertical asymptote, and that's because plugging in a 0 here will make the bottom 0. So that gives us a vertical asymptote at x equals 0. Okay, we can plot a few more points. We plug in -1. When x is -1, y is -1. Now looking at the graph paper, you can see some of our points are plotted. You may want to plot a few more points to see what the graph is supposed to look like, but if I connect the dots, this is what you get. Okay, and we don't actually see it, but there's actually a horizontal asymptote as well, and that's the x-axis. Okay, the dotted lines on the x and y-axis are just asymptotes, so they're not actually part of the graph. So what you see in the green is the actual graph. So this is how you would graph the reciprocal function. This is kind of like 1 over x, which was the reciprocal function, but this one is squared, so I'm just calling this the reciprocal squared function. This is another common function that we need to know how to graph. Okay, when I plug in -2, I get 1 over -2 squared. So that'd be 1 over 4. The two negatives cancel, so it's positive. Again, when you plug in 0, you're getting 0 on the bottom, so we have that vertical asymptote again in the bottom. If you look to the right, you can see the graph of the function. It's in green. The blue dotted lines are just the asymptotes. Okay, this next example is an exponential function. So it's a number to the x. When the number is greater than 1, it's going to look something like this. So we'll plug different values in and we'll see what we get. First example, we plug a -2 for the x. You get 2 to the -2. Right now it's over 1, and we can rewrite this. If we move the 2 to the -2 down, it becomes 2 to the +2. So you end up getting 1/4. So when x is -2, y is 1/4. Let's try another one. When you plug in -1, you get 2 to the -1. Remember, it's over 1. So if we move it down, you get 1 over 2 to the +1. So that's just 1/2. Let's do one more. Let's plug in a 0. You're going to get 2 to the 0. And 2 to the 0 is defined as just the number 1. So when x is 0, y is 1. Now you can look at the graph, we can plot all these points, and then we can connect the dots. Now the graph doesn't show it, but the x-axis is actually an asymptote. And this is an example of an exponential function. Okay, here's a different type of exponential function. In this case, the number inside is between 0 and 1. Anytime you have a number inside between 0 and 1, they're going to look like this. Now I'm rewriting 1 over 2 to the 1. Now this is 1 over 2 to the 1. If you move the 2 to the 1 up, it becomes 2 to the -1, just like you see right here, 2 to the -1. Now we can multiply -1 times x, and you just get -x. So you can see the same exact equation can be written in two different ways. Now if I use this one and plug in negative numbers, it's going to come out nicely. Plug in a -2, and it's going to give you 2 squared, which is 4. So when I plug in a -2, I get 4. Plug in a -1, you're going to get 2 to the -1, which is 2 to the 1, and that's just 2. So when you plug in a -1, you get 2. And these are all just points that I can plot on the graph. The 0 is usually an easy one. When I plug it in, I get 2 to the -0. So that's just 2 to the 0, which is 1. When I plug in 0, I get 1. Let's plug in a 1, and that'll give me 2 to the -1. 2 to the -1, you see it's over 1. If I move it down, it becomes 2 to the +1. 2 to the +1 is just 2, so I'm getting 1/2. So when I plug in a 1, I get 1/2. Plug in the last one. When I plug in a 2, I'm going to get 2 to the -2. So that's 1 over 2 to the +2. In this case, I get 1/4. So plugging in a 2 for x gives me a 1/4 for y. If you look at the right, plotted all the points, connected them. It looks almost like the other one, except that it's decreasing instead of increasing. So this is an example of an exponential function where the number inside is between 0 and 1. Okay, the next one we're going to do is actually not a function. It's the equation of a circle. In this case, we have x squared plus y squared is equal to 5 squared. And so that's obviously 25, but I wrote it as 5 squared because that means the radius is 5. Okay, we'll plug some points in and we'll get some values. I chose values that I know are going to come out nicely. I chose y is 0. Okay, this gives me x squared is 25. I have to do the square root of both sides. The square root of x squared is actually the absolute value of x. And we can change that for plus or minus x. And we can move the plus or minus over to the other side. So when y is 0, x can be 5 or negative 5. Okay, I plotted both points on the graph. Now I just plugged in for y, but now I'm going to plug in for x. Okay, I skipped some steps there, but y is plus or minus 3. So I can let the y equal 3 or negative 3. Okay, again, I plotted both points. Okay, when x is 3, get y squared is 16. Skipping some steps here, but we're getting plus or minus 4 for the y. Plot both points. Okay, let's just do one more. We plug in 0 for our x. You get y squared is 25. Skipping some steps here, but we end up with y equals plus or minus 5. Okay, again, the more points we plot, the better our picture looks. But this is just a basic example of a circle with a radius of 5. Now for a circle with a radius of 3, this would be 3 squared right here instead of 5 squared. And this is an example of the graph of a circle. Okay, now we're going to look at a linear piecewise function. Okay, for a piecewise function, it's only going to be this line when x is less than or equal to negative 1. So in this case, negative 2, negative 1. So let's plug these x values in and see what we get. You can see how we're getting the 0. When I plug in a negative 1, you can see how I'm getting the 1. Now the directions say that when x is greater than negative 1, it's going to be this function. So if we plug in a 0, get 2 times 0 plus 3, and that's just 3. So when x is 0, y is 3. You could also plug in a 1, 2 times 1 plus 3. Gives us the 5. And when x is 2, you're getting 7. Now these two lines happen to touch at the same point. When x is negative 1, they're both 1. But sometimes they don't touch. Sometimes you get something like this. But that's not what we have in this situation. So this is an example of a linear piecewise function.